All right. I'm actually, first time I'm going to teach a whole geometry lesson with nobody in your room. What we're looking at today, trying to do this way today because we are on a late start schedule, and I want to make sure that you get everything that you can get, because likely in class we wouldn't have time to cover all the material that we would need to for you to understand the concept and be able to work on your homework effectively. So we're looking at lesson 59. If you're in your ebook or your textbook, it's page 389. We're going to be talking about finding surface areas and volumes of prisms. So there's certain things I can't do on this video that I would be able to do in class, and we'll try to do in class, which is to show you or to bring out some manipulatives and solids for you to look at and really be able to see the lateral faces and be able to see the bases and how those things can be manipulated, as well as to steer away from some pitfalls that people typically fall into. All right, so let's get started here. The first thing we want to do is we want to look at some definitions. First off is surface area. Surface area is the total area of all faces and curved surfaces of a solid. So it's the area of absolutely the entire thing. So imagine that you are, wrapping a box, wrapping a present. And you're going to cover the entire outside of that with paper, except in this case, there's not going to be any overlap. So, if we were to talk about that, it'd be like taking it and spray painting it, for instance. And you're going to spray paint the entire outside of it. That would be the surface area of it. Okay, so total area of all faces and curved surfaces of a solid. So, does it have to be polygons? Okay, lateral area is the sum of the areas of the lateral faces of a prism or pyramid or the surface area, excluding the bases. So lateral area will always exclude the base of the total surface area of a cylinder or cone. So when it's a prism, and we're just looking for the lateral area, I want you to imagine like a can of soup. The label that's around a can of soup is the lateral area. Notice that it doesn't ever cover the top or the bottom of that can. So that cylinder that we see has a lateral area that excludes the bases. If we're talking about a pyramid or a cone, imagine taking the bottom off of it. Best way to think about a cone lateral area is to imagine an ice cream cone. Obviously, it's not solid across the top of that cone. Otherwise, we wouldn't be able to put any ice cream in it. That would be a sad day. Okay, so lateral area is going to exclude the bases of the solid. Okay, so that's the difference between surface area and lateral area. We're going to talk about the lateral area of a prism. Okay, and so we've got a formula here. The lateral area, L, of a prism can be found by using the following formula, where P is the perimeter of the base and H is the prism's height. Now remember, in a prism, the base is the polygon that is parallel. It'll be two bases that are parallel to each other. So the first thing you want to identify in a prism is, what are my bases? And in a prism, there should be two bases. They could be any given shape, but your faces will always be rectangles. So if it's a prism where we have an octagonal prism, then the octagons, even if it's laying on its side, even if it's laying on a rectangle, the bases don't change just because the orientation of the prism changes. And that's the hardest thing for a lot of people to get, especially whenever we see, like even with a cylinder or a triangular prism, is that we want to take whatever's on the bottom. And the bottom is not always the base. It is the sides, it is the polygons that are parallel to each other. So we're going to find the perimeter of the base, that's the P, and the height. Again, the height is not always the up and down, depending upon how it's oriented. Okay, the height will be perpendicular to the base. It is the length perpendicular to the base. So lateral area is going to be the perimeter of the base multiplied by the height, the line that is perpendicular to the base, or the length of the line that connects the two bases. All right, we'll look at some questions here after a little bit, and hopefully this will make a little bit more sense. But this formula that I've underlined, if I can, there, you need to write that down. And if you needed to, we could go so far as to be a little bit more specific here. Let's say lateral area equals, let's see, the perimeter of the base times the length of the line perpendicular to the base. Okay, that's my height. Lower that all down there. Okay, so hopefully that helps out a little bit. If nothing else, you've got your formula there. Next thing we're going to look at is surface area of a prism. Okay, surface area of a prism again is going to include all sides. So the surface area of a prism is the sum of the lateral area and the area of the two bases, where B is the area of the base polygon. This is the main difference that we see where we're talking about B. Notice that we're going to use a capital B here. We're used to seeing B in area formulas, like in the area of a triangle where it is base times height divided by 2, but solids are three-dimensional. So the base is the area of the base polygon. Okay, that figure that runs parallel to itself connected by these parallel lines or rectangles. So surface area here is going to be taking my lateral area, which if you remember is the perimeter of the base polygon times my height plus 2 times the area of the base polygon. The reason it's 2 times that is because in a prism we should have 2 bases. So imagine that, imagine that can of soup again. If we found the lateral area, then we're going to add on the top and the bottom to find the surface area. Okay. Then we've got volume. If we want to find the volume of a prism can be found by using the formula below, where B is the area of the base polygon and height is the height of the prism. Volume equals area of the base polygon times the height of the prism. Again, the base and the height won't change. It is not based upon orientation. We can change the orientation. We can take that can of soup and knock it over on its side. It's not going to change where the base is located or where the height is. Okay, sometimes we get stuck on height as being up and down. But remember, you are your same height whether you're standing up or laying in your bed. You are the same height. Okay, your height did not change, your orientation did. Okay? All right, right prisms. And again, this is going to be one where unfortunately I don't have a figure to show you. Maybe I do if I can find some shapes up in here. I don't know that they give me, they don't really give me any three-dimensional solids, cones, cylinders, those types of things that I know of. That or I just don't know how to do a lot of this stuff. Let's see if there's anything in here. No, they're all two-dimensional. Okay, but hopefully we'll certainly see some in our work here in a little bit. But a right prism whose lateral faces are all rectangles and whose lateral faces are perpendicular, that's the important part. A right prism is going to be perpendicular, okay, to both bases. Okay, in a right prism, the height is the length of one edge that separates the bases. Okay, separates, or you could say connects them. Then we have an oblique prism. Let me see if I can move this guy around here a little bit. Now this has a long explanation to it, but imagine if a cylinder is right, okay? You look at a can of soup, it's right, meaning that the line that connects the top and the bottom of that soup can is at a right angle with the base. An oblique prism would be, a good example of that would be like the Leaning Tower of Pisa. It's a cylinder, but it's leaning, right? It's tilted, it's kind of even twisted. A prism that has at least one non-rectangular face, so really a cylinder doesn't work very well for that, but you're taking it and you're shifting it. An oblique prism is like a prism that has been tilted to one side. The surface area and the volume aren't going to change, so we can use the same formulas that are used with a right prism. But instead of using the height of a lateral edge of the prism, we have to use an altitude. So we actually have to find a distance from the top to the bottom, and it has to be a perpendicular line to the base. So if I shift it, if I tilt it, it's no longer perpendicular, so it's no longer the height anymore. So we need an actual for real altitude. An altitude of a prism is a segment that is perpendicular to and has its endpoints on the planes of the bases. So we might see one of those here in a little bit too. And I think that's it for that. So let's actually look at, oh, no, wrong thing here. Oh no. All right, let me pull this up again. Hopefully I can get this to show up and we can work out some questions. Okay, lesson 59. Question number 1, I think we've got like 5 questions in here, so not a whole lot. Question number 1, a right rectangular prism, so not oblique, has a length, width, and height that are all equal. The volume of the prism, let's move this over so I can see them, is 1,331 cubic meters. Find the surface area of the prism, okay? It is a right rectangular prism where the length, width, and height are all equal. So you may not have gathered this, but whenever they're telling me the length, width, and height are all equal, and it's rectangular, what I am seeing, and it's a rectangular prism, so let's see something like this, where the length, the width, and the height are all equal. The volume is 1,331 cubic meters, so we know the volume. Find the surface area of the prism. So what I actually have here is a cube, which is a rectangular prism, but it's a cube. So in a cube, volume is found by side cubed. All right, so what we know is that 1,331 equals side cubed. So if I want to find the length of one side, I have to cube root 1,331 to find the length of one side. So I'm going to pull up my calculator here, and I could probably do our cake method, but let's go to math, because math is going to have a cube root for us. 1,331. That tells me that each side measures 11. All right, so I got 11 here, 11 here, 11 here. They're asking me to find the surface area of the prism, not the lateral area, but the surface area. And if you remember in our definitions, surface area is the area of all sides. Area of all sides. Or we know that surface area, they gave us a formula for that. Let's move this back over here. The formula for surface area equals lateral area plus 2 times the area of the base polygon. Okay? We could be a little bit more specific and say that surface area equals the perimeter of the base polygon times the height plus 2 times the base. Okay? Could even be even more specific here with our shape. So the perimeter of my base polygon, again, my base polygon, if I make this even a little bit more three-dimensional, I know that this is 11, I know that that's 11 there. This is my base. Okay, so the perimeter of the base is the distance around it. Okay, so 11 times 4, or 11 plus 11 plus 11 plus 11, which should be 44. Okay, so we got 44 times my height, which is 11. Okay, my height is 11, plus 2 times the area of my base. Well, my base here is 11 by 11. 11 times 11, if I'm not wrong, is 121. So 44 times 11 plus 2 times 121. All right, let's try that. 44 times 11 plus 2 times 121. Okay, it comes out to 726 meters, because it's area, surface area, 726 meters squared. Now, there is another way to do this, just because I know it's a cube and I know that surface area is the area of all faces. A cube actually has 6 sides, and all areas are congruent. So if I know that the area of one side of a cube is 11 by 11, so it's 121, I could take 6 times 121, or 6 times 11 times 11, okay? Okay, just so we're seeing where we got that 121 from. Okay, 6 times 121, 726. 6 times 11 times 11, 726. I get 726 in all of that. So I don't necessarily care on a cube. You can do that work right there, but that won't work on all rectangular prisms. Only cubes. One of the questions I was referring to, that a lot of people do this wrong because they assume that the rectangle down here on the bottom is the base, and that this line right here is the height, and it's not. Because remember, our base is not the bottom polygon, it is the base polygon, and the base polygon is the polygon that has a parallel side to it. So the base here is actually my triangle. So in order to find the volume of this, it is the area of the base polygon times the height. So my blue triangle here is my base polygon, and my height is right there. It's the 14 feet. So in order to find the volume, I need to find the area of the base polygon. Base polygon of the triangle. In order to find the area of a triangle, we do base times height divided by 2. Right? So I have, two different definitions of height here. One height, this height right here, is the height of the two-dimensional figure. My height here is the height of the three-dimensional figure. Okay, two different definitions for height. And we're using big B for area of the base polygon, little b for base of the two-dimensional base. Okay, it's the base of the base. Okay. All right, so let's fill in some information on that part. Okay, the base of that triangle is 10. The height is 4, and we're going to divide by 2. Okay, and then our height, that we're going to multiply all of this by, is 14. So 10 times 4 is 40. 40 divided by 2 is 20. 20 times 14. I don't know that one off the top of my head. Okay, 280, and I believe we're talking feet, and because it's volume, we are cubed, okay, because this right here is in units squared, and this is in units to the first. Units squared, unit to the first, add those, we get units cubed, okay, that's how we get that. All right, so again, don't let the orientation mess you up. Okay, number 3, find the lateral area in square inches of this rectangular prism shown below. Lateral area. Lateral area does not include the bases. Here, the base are those parallel triangles here and here. We're not going to include those areas. So, in order to find lateral area equals the perimeter of the base, okay, times the height. Essentially what we're doing is we're finding the area of these 3 rectangles, okay, that we're going to add together, okay, if you can see that. But let's find our base, or sorry, let's find our perimeter, okay. Okay, let's see, in square inches, it says here, we want to use all the information it gives me, is a regular triangle. And a regular triangle means that all my sides are the same length, all my angles are the same. Because that side of that triangle is 1, then I know this is 1, I know this is 1. 1 plus 1 plus 1 equals 3. So I have a perimeter of 3 and a height of 5. Okay, so my lateral area is 15 inches squared. Okay, 15 inches squared. It's not the only way to find it. You can kind of common sense some of these. That if I've got this rectangle here, okay, that rectangle right there is 5 by 1, so 5. This one is 5 by 1, so it's 5. And believe it or not, this one across the back, okay, is 5 by 1. So there's your 1, okay, and it's 5 tall as 2. So you're winding up with, 5 inches squared plus 5 inches squared plus 5 inches squared, still giving you 15 inches squared. But I'd rather use the formula because you're going to need to know it and you're going to need to practice with it. Okay, 4. Find the volume in cubic feet of a right prism. Okay. If the base is 8 feet by 6 feet, rectangle. Okay, so my base is a rectangle. It is 8 by 6, and they tell me that it's a prism. Okay, so it must be kind of like this. Try to something like that. Okay, the base is 8 by 6, and the height is 4. Okay, we want to find the volume. All right, so a number of ways to do this, but in a prism, it's length times width times height. But if you'll remember our volume formula, let's go back and look at our notes and see if we can remember what that is. Okay, volume of a prism is area of the base polygon times height. Okay, area of the base polygon times height. So volume equals area of the base polygon. So because it's a rectangle, it's 8 times 6 times the height of 4. So it really is length times width times height. 8 times 6 times 4. 8 times 6 times 4, which is 192 feet cubed. Right? If you want to understand that cube part again, the 8 times 6 is giving me units squared. The 4 is giving me units to the first. That's giving me units cubed. Okay, 192 feet cubed. That's the work that we need to see on that question. All right, one final question here, number 4. Now, you'll notice this one, I'm glad that this showed up in here because this is an oblique prism. All right, and we want to find the volume. Well, volume, the formula doesn't change. It's area of the base polygon times the height. Okay, in this case, base times height divided by 2 times height. But what you have to remember is because it's oblique, my height is actually the altitude. Okay, so we're going to substitute A for H. Okay, all right. Let's see, my base polygon here is my triangle. Okay, even though it looks like the rectangle is, but it's my triangle. So my base is 21. My height is 14. And I'm going to divide by 2. Now the next thing I need to figure out is what is the altitude? Because it is not 35. It is in fact 29. Okay, 29. Okay, and they'll typically represent the altitude as a dotted line. So after we plug this in, okay, we'll find our area of our base polygon first. So let's come over here and do that. We've got 21 times 14 divided by 2 times 29. Okay, giving me 42,063 centimeters cubed for my volume. Okay, again, this is area, so it's units squared. Height is just units to the first, giving me units cubed. Okay, and that's why we get centimeters cubed. All right, so that's all the questions on the lesson notes. Should give you plenty of time to get started on your homework. Hopefully you understood most of this, and I'll be around to answer questions from your homework for you or with you as you go. So I hope this video worked out well for you, and it's good use of time here. Okay, all right, great.